People keep asking whether DeepSeek Harness can replace Claude Code or not. But I think most comparisons are answering that question the wrong way. If Claude Code is running a model and that model is Claude model and DeepSeek Harness is running a DeepSeek model and one of them wins, what actually won? Was it the model or was it the harness around the model? Those are two different variables. So instead of pretending I ran my own benchmark, I went looking for a comparison that actually keeps the model fixed. And Composio published one that is more useful than anything ever over the internet. They took the exact same model, DeepSeek V4 Pro, at max reasoning and ran it through different agent harness. So it's about the same model, same 30 hard tasks, same tools, same verifier checks. The main thing changing was the harness tool. And to be precise, these were not 30 software engineering benchmark coding issues. They were hard agentic tool asked against real applications. So I won't treat this as a pure coding leaderboard. But it is a very clean way to see how much the wrapper around a model can actually matter. DeepSeek Harness passed 20 out of these 30 tasks, that is 66.7%. Claude Code passed 19 out of 30. This is 63.3%. So first, no, DeepSeek did not destroy Claude Code. It won by only one extra task. On a 30 task test, I would call that close but not a revolution. But then I looked how they got to those answers, and this is where it becomes much more interesting. DeepSeek Harness used an average of 88,562 tokens per task. But on the other hand, Claude Code used 649,900. That is more than 7 times as many tokens for Claude Code on the same model and on the same task set. Read that again in another way. The model did not change. The task also did not change. The tools did not change. But the amount of model work changed dramatically. And it's totally depending on the harness around it. Composio also reported an average of 0.9 turns per task for DeepSeek Harness compared with 12.1 for Claude Code. I would not overinterpret that number because different harness can structure a turn differently. But together with the token count, it tells us something important. A harness is not just a pretty terminal sitting in front of an LLM. It changes a lot how the model is prompted, how tools are exposed, how state is carried forward when the model gets called again and again, and how the whole agent loop behaves. And that can completely change the efficiency of the exact same underlying model. The cost numbers tell a similar story. For tasks that both systems successfully completed, Composio reported a cost per shared success of about 2.8 cents for DeepSeek Harness and 7.4 cents for Claude Code. So Claude Code was roughly 2.6 times more expensive on that shared success comparison. And that does not mean DeepSeek Harness is 2.6 times better. It means the same model can have a different cost profile depending upon the harness you put around it. And this is why I think DeepSeek Harness is more interesting than the usual headlines make it sound. DeepSeek did not release another model here. Harness is the agent runtime around the model. Think of the model as the engine. The harness is just rest of the car. The tools, the interface, the agent loop, the session, the storage, the permission, and the way all of those pieces talk to each other. DeepSeek design principle is literally that everything would act like a plugin. Even the model is a plugin there. So instead of building one tightly integrated coding agent where most of the stack is fixed, the idea is that you can replace pieces of the system without rebuilding. And that could be everything around them. That matters if you want to move between the frontier API model or an open weight model or something that you want to serve by yourself. And for researchers and engineering team, this is much bigger idea than asking whether one agent finished a demo 5 seconds faster than another one. It means the model and the harness can become separate engineering decisions. Maybe you want one model for the coding and another for the debugging. Maybe a cheaper open model is good enough for repetitive tasks. Maybe you cannot send a repository to an external provider at all. So the model has to stay on your own infrastructure. A more modular harness makes those choices much easier in principle. But there is a big reason I would not tell everyone to uninstall Claude Code tomorrow. DeepSeek itself stated that harness is still in development preview mode. So that means the official repository explicitly wants that there will be compatibility breaking changes happening around that repo. Claude Code is a mature product. DeepSeek Harness is currently a much more experimental and composable runtime. Those are not the same thing. If I were shipping the production code today and I care mostly about a polished daily workflow, Claude Code still has a various obvious advantage simply because the product is much more mature. But if I care about controlling the model, the tools, and the agent architecture separately, DeepSeek Harness becomes very interesting over that part. And the benchmark is useful because it exposes something I think we often miss when talking about AI coding. We obsess over model leaderboards. Model A scores 68, Model B scores 72. Everyone argues about the 4-point gap. But here, the model was also identical. Just changing the harness moved the pass rate from 63.3 to 66.7% and changed average token usage by more than 7 times. That tells me that the model benchmarks alone are not enough anymore. For agents, we need to benchmark the model and the harness as the pair. And that is probably the real story behind DeepSeek Harness. Not that it has already killed Claude Code. That's not a fair comparison, and it has not done that. The interesting part is that the software around the model may matter almost as much as the model itself for the cost, efficiency, and whether the agent actually finishes the job. So if you are evaluating AI coding agents this year, do not only ask which model is the smartest. Ask what is wrapping that model, what tool it gets, how many times it has to call the model, how much context it burns, and whether you can swap the pieces when something better comes along. Because as this benchmark shows, keeping the model exactly the same does not keep the results same. And that is the part I think is worth paying attention to.